When you think about farming, there's this one idea that just seems like common sense. To get bigger crops, you just have to add more fertilizer. It's logical, right? More plant food should mean more people food. But what if that basic idea is just wrong?
Okay, so let's really get into this, because a brand new study is taking that old way of thinking and turning it completely upside down. We're going to break down how some seriously tiny technology is making a huge difference by proving that, yeah, sometimes less really is more.
For the longest time, the strategy in agriculture has been pretty simple. Just keep adding more nutrients to get a bigger harvest. But scientists are starting to take a step back and ask if this is really the smartest way to go.
I mean, this whole more is better approach has its fair share of problems. Fertilizer runoff can mess with our waterways. And as we're about to see, some of the super high concentrations in modern fertilizers could actually be a risk to our health. There's got to be a better way, right? And this is where things get really cool. Let's meet the hero of our story, a new kind of nanoparticle that's totally eco-friendly. And what's wild isn't just what it does, but how it's made, using some incredibly simple green ingredients. So, we're talking about silver nanoparticles, or AGNPs for short. Just try to picture this. Particles of silver so incredibly small that you could fit millions of them on the head of a pen. And at that tiny, tiny scale, materials start to act in completely new and powerful ways. Scientists figured, hey, maybe this could be a total game changer for growing plants. Now, what's really amazing here is just how simple the recipe is. This isn't some crazy, complicated industrial process. No, researchers made these nanoparticles using plain old rice starch. And the starch acts like a natural coating, a stabilizer, that keeps those tiny silver particles from clumping all together, which is absolutely key to making them work. And this diagram here, it basically lays out the whole journey for us. Over on the left, you see the simple ingredients going in. Then in the middle, you see the nanoparticle solution being created and sprayed onto the onion crops. And finally, on the right, you see the harvest and the analysis. It's this beautiful, elegant loop, from a simple idea all the way to a powerful result. And here it is, the visual proof. This is what it looks like under a super powerful electron microscope. You can actually see the nanoparticles. They're these perfect little spheres, all tiny and evenly spaced out. That perfect structure, all thanks to that simple starch recipe, is really the secret to their power. All right, so our scientists have their new green nanoparticles. They've checked them out, they look perfect, so what's next? Time to put them to the test. They set up this amazing head-to-head competition in an onion field, pitting their new creation against stuff that's already on the market. So let's meet our fighters. In this corner, the challenger, our new green-silver nanoparticles, used at a ridiculously low dose of just 20 parts per million. And in the other corner, the defending champs, commercial nanofertilizers, used at their recommended dose, which is all the way up at 2,500 parts per million.
And just to help you wrap your head around that dose, 20 parts per million it's almost nothing. It's like 20 seconds in a whole year. It's like 20 drops of water in a giant bathtub. We are talking about a truly microscopic amount here.
So let's just let that sink in. The commercial products were being used at a dose that was up to 125 times higher than the new green nanoparticles. Now, based on that old more is better idea, this should have been a total blowout for the commercial stuff, right? So the onions grew, they were harvested, everything was weighed and measured, all the data came in. So, who won the showdown? Well, the results were not at all what you might expect. Let's start with the total weight of all the onions harvested. The control group, the one with no nanofertilizer, got 9.7 tons. The commercial product, with that massive dose, got it up to 12.5 tons. Pretty good. But then look at the green ag NPs. At a dose 125 times smaller, it produced a slightly higher yield, 12.53 tons. Wow. And it's the exact same story for what they call marketable yield. The onions that are actually good enough to sell in a store. Once again, the 20 ppm green nanoparticle treatment just barely edged out the 2500 ppm commercial one. That's just an incredible result. Way, way less input for the same, if not slightly better output. But hold on. Here is the real knockout punch. When they looked at the average weight of each individual onion, the green AGNPs were the clear, undisputed winner. They grew onions that were heavier, bigger, and more substantial than both the control group and the ones getting those super high commercial doses. And hey, don't just take my word for it. The scientists themselves put it right in their conclusion, plain as day.
They said that their 20 ppm green nanoparticles consistently gave the best results. Better growth, better yield, better quality, all while outperforming commercial products that needed very high doses.
And they did not mince words about the other stuff either. The paper literally calls the commercial concentrations crazy doses. They warn that because these particles are so tiny, using such high amounts could let them build up in the soil and water over time, a process called bioaccumulation, and that could eventually pose some real risks to our health.
So what does this all mean for the future? Well, this one experiment on onions could signal a massive shift in how we think about growing our food. It's a move away from just brute forcing it with more stuff and toward a smarter, more precise, and ultimately safer way of doing things.
So what's the big takeaway from all this? Well, it all points toward a new kind of fertilizer, one that's made in a sustainable way, is safer for the environment, and better for us. It gets better results using way less material, which cuts down on waste and potential toxins. I mean, it is the absolute definition of working smarter, not harder.
Which leaves us with one last really powerful question. We've got this massive challenge ahead of us. How do we feed a growing world without destroying the planet in the process? And maybe, just maybe, the answer isn't about doing more, but about thinking smaller. Much smaller.